So I would actually rewrite this. This is the integral of x, natural log of x to the 1/2 dx, which then becomes the integral of x times, bring the exponent down. Now remember, you're going to end up in the same place, no matter what, even if you don't do this. But it makes your life so much simpler. So this is going to be 1/2 x natural log of x dx. So that's my integral. What's this the case of? Who do I need to get rid of? Natural log. It's a case of disappearing function. So I'm going to differentiate natural log. And that means I'm going to integrate 1/2 x dx. So that u is going to be natural log x, so that du is 1 over x dx. dv is 1/2 x dx. And if I integrate both sides, then v is 1/2 times, what's the antiderivative of x? X squared over 2, which is 1/4 x squared. Because it's easier to handle it that way. So the integral of x natural log of the square root of x dx, that's the original problem, is, now I 7 it, u times v, which is natural log of x times 1/4 x squared, minus the integral of v, that's 1/4 x squared, times du, which is 1 over x dx. So I always put the variable in front of the natural log of x. And this is 1/4. What's x squared times 1 over x? Is this integrable? Yes, yeah. So this is 1/4 x squared natural log of x minus 1/4 times x squared over 2 plus c. What's the next one? Who gets integrated, who gets differentiated?
Either the negative is differentiated.
This guy never goes away. So if you think about integrating this thing, this becomes a 3x minus 5x squared over 2. And then you're going to multiply these two things together, and I've just multiplied and doubled my problem. So when you've got e to the x involved, he's always going to get integrated because he never goes away. So remember, it's either the case of the disappearing variable or the case of the disappearing function. So if you're going to differentiate e to the x, is it ever go away? So he'll never disappear. Will this disappear? Yeah. So u is going to be this thing. And since e to the x never disappears, dv is going to be that guy. So u is 3 minus 5x, so that du is 3 is 0, minus derivative of minus 5x is just 5. So you can always already see this thing is just now going to be a constant. dv is just going to be e to the minus x dx. Integrate both sides, so that v is going to be what? Negative e to the minus. You're going to see this occur all over time. So now we 7 it. So this becomes, the original problem is 3 minus 5x e to the minus x dx is u times v, 3 minus 5x. V is going to be, I'm going to put the minus in front, e to the minus x, minus the integral of v minus e to the minus x times du, which is minus 5 dx. The thing is this integrable? Yeah. This is then becomes minus 3 minus 5x e to the minus x. Now you could say minus and a minus is a plus, but I've got a minus, and a minus. This minus and a minus forms a plus, and so I'm still going to have a minus. And the integral of 5 e to the minus x dx, that's integrable, because we've already done it. So this becomes minus 3 minus 5x e to the minus x minus 5. Now what's the antiderivative of e to the minus x? Negative e to the minus x plus c, which is minus 3 minus 5x e to the minus x plus 5 e to the minus x plus c. Now, can you see kind of where things can fall apart on you? In this particular instance, it's not going to be the fractions that get you, it's going to be the minus signs. Because there's minus signs all over the place. So you might end up with the correct form of the answer, but a wrong sign.